In this episode, I will go over practice problems 5 through 8 from my logarithms video. Let's get started. So we're kind of starting a new type of section here, if you will. Problem number 5 states that the log base 4 of x to the third power equals 3. So, how do we solve this one? Well, there are two ways that you could solve this. The first way is to use the third property of logarithms. So here is the third log property. It states that the log base a of u to the n power is equal to n times the log base a of u. Well, how does this help us? Well, basically, it means you can take whatever's in the power position of the term that's down here and move it outside. So, we're going to do the same thing to this 3 up here. This is x to the 3 power, which is basically our version in this particular problem of u to the n power. And we're going to take the 3 and move it out front of the logarithm so that it's a multiplication. So, here's what it looks like. 3 times the log base 4 of x equals 3. Okay, how does this help us? Well, now we can divide both sides by 3, like this. This cancels out 3 on this side, and 3 divided by 3 is equal to 1, because any number divided by itself is equal to 1. So this becomes a 1 down here, and this becomes log base 4 of x equals 1. And now we can use the BAP method. This is the base. This is the answer. And this is the power. So now you know that if you raise the base to the power, you get the answer. So in our case, 4 is the base, x is the answer, and 1 is the power. 4 is the base, 1 is the power, and x is the answer. What's 4 to the 1 power? Well, anything to the 1 power is just itself. So 4 to the 1 power is 4, which means that x equals 4. And that is our answer to question number 5. The second way could be a little bit easier to some of you, and it could be a little bit harder to others of you, but it does require some knowledge of the properties of exponents. So here's what we're going to do. Instead of moving this power out to the front, we're going to use the BAP method right off the bat. So if this is the base, and this is the answer, this whole thing here, by the way, and this is the power, this is the base over here, this is the power, then if you raise the base to the power, you get the answer. Well, the base is 4, the power is 3, and the answer is x to the third power, the whole thing, everything inside these parentheses. So now, without even doing 4 to the third power, we can just find the cube root of both sides. And remember, because this is an odd number, we don't need to put positive or negative in the front. And this cancels out the 3 powers, which leaves us with 4 equals x, which is the same answer that we got last time. X equals 4 is the answer to 5, no matter which way you solve it. Now on to problem number 6. So, problem 6 states that 2 to the x power equals 8. The thing you're trying to discover is, what power do you need to raise 2 to get 8? Does that sound familiar? So there are two ways you can solve this. You can solve it through trial and error and critical thinking, which is where you think to yourself, okay, what power do I have to raise 2 to get 8? Well, I know that 2 squared equals 4, and 2 to the third power equals 8. So, oh my gosh, there it is. x equals 3 is the answer to problem number 6. But it isn't always that easy. Sometimes this is just too big a number or too hard of a number for you to figure out what power you need to raise this to get that number. For that method to work, you have to know what power to raise 2 to get 8. How can you do that if you have a number that's ridiculously huge? Well, if you have a calculator with you, you can actually use logarithms to help you find your answer. And odds are, if you're given a problem on a test or on a homework that the number is too large for you to guess through trial and error, you will probably have a calculator. Either that, or you will have a different method for solving these types of problems. So, you need to say to yourself, what exponent do I need to raise 2 to get 8? Well, if you remember from my video earlier, that's what a logarithm is. The log base 2 of 8 is the logarithm you have to raise 2 to get 8. So how do you plug this into a calculator? Well, you use the method that I taught you in my last video. That property states that the log base a of x equals the log base b of x over the log base b of a. So we're going to use that property, where in this case our a is 2 and our x is 8, and our b, I'm going to use the constant e. And if you remember from the video, e is just a constant number, just like pi. So if log base b is, for this problem, log base e, log base e is the same as the natural log of something. And we have the natural log on our calculator. So if we set this equal to the natural log of 8 over the natural log of 2, that's something we can plug into my calculator. So that means that our answer to this problem is just 3, because the log base 2 of 8 equals 3, which means that the exponent you have to raise 2 to get 8 is 3. So if you raise 2 to the third power, you get 8. This can be used for much more difficult problems than finding out what number you have to raise 2 to get 8. So now that we have this, we can replace 8 in our original equation up here with 2 to the third power, because we know that 2 to the third power is equal to 8. So we now have 2 to the x equals, which is from up here, 2 to the third, which is the same as 8. So let me show you the complete drawn-out mathematical way of doing this. 2 to the x equals 2 to the third power, right? Well, once you get it so that there are like bases, 2 raised to some power, then you can set the powers equal to each other. Because if you raise 2 to some power, and then you get 2 to some power, the powers have to be the same. And even if you can't think of it that way, you can find the log of both sides by going like this. The log of 2x, and remember to find the log of the entire side, equals the log of 2 to the third power. Then we can use the third property of logarithms, which I've written up here, which states that you can take an exponent out in front and have it being multiplied by the logarithm. So if we do that to this, take the x out front here, and take the 3 out front here, we get x times the log of 2 equals 3 times the log of 2. Well, guess what? Now we have a common term on both sides, and if we divide both sides by the log of 2, the log of 2 will cancel out on both sides. You can just cross it out. And then you're just left with x equals 3, which is again the answer to our problem number 6. Now on to problem number 7. So problem number 7 states that the log base 5 of x is equal to the log base 5 of 3. Well, this one is relatively simple. I'm going to walk you through the technical way to solve it first, and then I'm going to show you the shortcut. So the technical way to solve it is to realize that the bases of these two logarithms are the same. They're both 5. So you just exponentiate both sides of this equation, which basically means you put a 5 on both sides, and then you make both sides of the equation into the exponents. So like log base 5 of x is the exponent on this side, and log base 5 of 3 is the exponent on this side. So you take this and turn it into the exponent that you're raising 5 to. How did I choose 5? Because 5 is the base of both of these logarithms. So how does this help us? Well, log base 5 of x is the exponent you have to raise 5 to get x, right? So if you raise 5 to the exponent you have to raise 5 to get x, what are you going to get? The answer is x. Sorry, I made a writing mistake here. This was supposed to be log base 5 of 3. I forgot to write the g. Sometimes that happens with me. I have a visual tracking disorder, and that makes me miss little things like that. So, moving on, if you raise 5 to the exponent you have to raise 5 to get 3, you're going to get 3. So that means that x equals 3 is the answer to problem number 7. So here's the shortcut way of doing it. All you need to do is recognize that these two bases are the same. So the log base 5 of x has the same answer as the log base 5 of 3. So that means that x must be 3 for these two sides to be equal to each other. Does that make sense? The number in the answer position has to be the same if these two whole logarithms are set equal to each other. So that just means that you can cross out the log part and just get x equals 3. That's the shortcut method. So there's our answer to problem number 7, x equals 3. Now on to problem number 8. Problem 8 is the same sort of problem as problem number 7. Problem 8 states 2 times the log of x equals the log of 9. So what do we do here? Well, the first thing we have to do is use the third property of logarithms, which states that the log base a of u to the n power equals n times the log base a of u. But this time, we're going to do it backwards. We're going to move the number in the n position up into the exponent position. So we're going to move 2 up into the exponent position on this x term here. This will leave us with the log of x squared equals the log of 9. Now we're going to use the shortcut method from problem number 7. These two logs have the same base. Remember that when you just see log, there's an imaginary base 10 down here. So we can just cancel out these two logs because they have the same base, leaving us with just x squared equals 9. Then you find the square root of both sides of the equation, leaving us with the square root of x squared equals the positive or negative square root of 9. Remember, because there's an imaginary 2 in here, that's an even number, which means that you have to place plus or minus in front of it. The square root of x squared is just x, and the positive or negative square root of 9 is just 3. So these are our two answers to problem number 8. X equals negative 3 and x equals 3. Let me quickly show you the non-shortcut method in case you didn't quite understand what we did over here. This step stays the same. We move 2 to the power position, leaving us with log of x squared equals log of 9. And because there is an imaginary 10 down here, we're going to exponentiate both sides so that 10 is the base of the log x squared power, and 10 is the base of the log of 9 power. So the log of x squared is just the exponent you have to raise 10 to get x squared. So if you raise 10 to the exponent you have to raise 10 to get x squared, you get x squared. And if you raise 10 to the exponent you have to raise 10 to get 9, you get 9. And then you move on to this stage to solve the rest of the problem. In the next episode, I will go over practice problems 9 through 12. I hope this helped. Please leave any questions in the comments section. Remember to subscribe and follow me on Facebook and Twitter. And remember, you can be good at math. Bye!